So I'm going to start with this panel with two apologies and a confession, which is probably kind of an odd way to start considering where we are. But as I think the room will agree, words have their power. And the words on this paper actually had a power over me. They are compelling me to start in this somewhat unorthodox way. So if you think that's odd, blame her. I appreciate it. So apology number one. I'm a practitioner by training and also by background. And because of that, and by temperament. And because of that, when I read a research paper, I naturally jump to the implications. I can't help it. I want to ask, does this research do anything for that student who I remember in my classroom or for the teacher that I work with? I'm sorry. I want to jump there. It's the only way I can say anything halfway intelligent. So I apologize to the room for that one. So for a moment, I'm going to live in that land of implication. That leads me to the confession. For over 10 years, I was a GED teacher. And when I was reading this paper, yay, I never get that, but GED, woo. When I was reading this paper, I was reminded of a type of student who I ran into countless times over those 10 years. Smart, capable, hardworking, and I would be in front of that student and I would feel that student knows their stuff. They can go test. And then they would go test and they would fail. Not by a lot and always by about the same amount. With time and with patience on their part, we usually could figure out what the issue was. And the issue usually was a matter of process. They were like hikers on a trail who suddenly had, when they hit a certain kind of problem, the trail vanished before them. They were lost. They didn't understand the sequence of steps that could get them from where they were to where they needed to be. And so as a teacher who knew that this population was not going to stick with me for too long, as I was like pulling my hair trying to figure out what those processes were, I cheated it. And what I did was I just kind of developed a series of sequences that would map to certain kinds of problems, and then I would drill that student until they memorized those sequences. Now, we had success in that, but I failed those students because I didn't have enough data to properly teach them. All I did was just cheat it so they could get that credential. But we all know that what divides success from lack of success is not that credential, but the ability to solve a problem. And so I failed those students. So when I'm reading this paper and I'm thinking about, now I know Dr. Heat will not, we're not talking about the GED, they're talking about a different test, but they are talking about the idea of computer, driven assessments that are based on the computer. In my current job at Digital Promise, one of the things I have to do is I go around the country, I try to find forward-thinking adult learning institutions that are incorporating technology. And even in those institutions, you hear so many teachers saying, God, why did we go to computers to the GED? It just adds another level of complexity. And I'm willing to kind of agree with that. But this kind of paper, what this paper kind of gets at is that there is an ability, we need to rethink the assessment process and not think about it just as it's a way to tell us if the student knows correct from incorrect, but it gives us a way to map that process so that teachers like me don't have to either create a crazy workaround or frustrate their students to the point that they leave. So I'm thankful for that.
Thank you.
So I guess we should get to it, right? Because the implications are great, but you have to get there. There's a process to getting those implications, and I hope that over the next 40 minutes, we can follow this process. And that process is, we'll have Dr. He, and will Dr. Matthias speak or not?
I don't think Matthias will be present.
Matthias will not be speaking, but his presence will be felt. And we'll get at what the paper is saying. Hopefully, through questions and answers and through our discussant, we'll get at what research can lead us to the implications, as unfounded as they are, as the ones like I want to find, right? And then hopefully maybe we'll even think about other implications that this research can have. So with that said, I will briefly introduce. Dr. Hay is an associate research scientist at ETS. Her background expertise are in psychometrics, data mining, text mining, and natural language processing with a focus on building applications for educational and psychological technology. She currently focuses on the exploration research of process data in large-scale assessments. Dr. Matthias von Davier is a senior research director in the Research and Development Division at ETS. He's the editor-in-chief of the British Journal of Mathematical and Statistical Psychology. He earned his PhD in psychology from the University of Kiel in Germany. His interests involve extensions of item response theory, diagnostic models, latent class analytics, mixture distribution models, as well as computational statistics and model data fit. Thank you. Dr. Hay?
Okay, it's my great honor to stand here to give the presentation today. Actually, it's a joint work together with Dr. Matthias von Davier, and unfortunately, he cannot come here to join us, but he will be on the phone. So if you have any questions that I cannot handle, so I will pass over to him. Yeah. So I think my topic is a little bit special. It's not really comparable with other studies we have learned so far at the conference. So I will explain something about exploring response patterns in problem-solving items using the process data. Actually, it's a kind of, you can gain more insights from the log files of a kind of problem-solving items in the PIAAC. Today I will briefly go over my outline. It's something like we have background, and I will introduce something about computer-based testing and PS-TRE items in the PIAAC. And also I will introduce what kind of process that we are using now in the log files. And also I will present the motivations and the research questions of why we want to do this kind of research. And second part, I will introduce what kind of method we are using to approach this kind of thing. So I will introduce the sample and instrument, and also introduce the methods we explore the response patterns. And finally, we will share with you some results and also the discussions. Finally, I will draw the conclusions and give you the future work. Okay, first let's see something about background, about computer-based testing and process data. And you can see actually nowadays we use computer-based testing more and more often, and there are quite a lot of benefits we can gain from that. For example, we have the flexibility when you use computer-based testing, and also it can enhance the security. And of course, we can get availability of immediate scoring. And also when we use computer-based testing, it can be consistent and reliable. And also, it will streamline our logistics and facilitate our administration of the testing. And also, we can engage navigation and presentation. But the most important thing we find in our study is that because in the computer-based testing, we have rich data. So that means besides we can get the responses from the students, but we also can collect more data from them. For example, we can collect more timing data or the action sequences from the students. And the other way we think is very important is because in the computer-based testing, actually we can, it gives us possibility to create more innovative item types. For example, in the PIAAC test, actually we can have the problem-solving item. It's a kind of a scenario-based things. So in my study, we will focus on two things. The first thing is the rich data because we use the process data. And the second element is we use advanced item types, it's PS-TRE items. Okay, what is process data and process from log files? Actually, I can show you an example. Look at this bucket of cherries. And suppose this is kind of results we can get from the students. It's kind of a fruit over there. But we want to track back how we can get this bunch of cherries. So we track their actions there. Look, this is a small guy, and this little guy, at first, he finds there some cherries very tall, so he's sitting on his daddy's shoulder and to catch the cherries. And then he finds there some lower ones, so he gets cherries, and he put all his cherries into his bucket. And then so follow the arrows, he find, oh, there are some other cherries, he can reach them by toes, standing by toes, and he catch them, and he put all his cherries on his bucket and happily go back home. So this kind of things actually is our focus on. We focus on the action sequences of how the students can get the cherries. And actually, this is my son. I need to thank for him to allowing me to show his picture here. And also, you can see, actually, we store the log file on the platform in the log files. So this is an HTML file in the log files. We can get it from the platform directly. And we call them as the raw log files. But this kind of things actually is quite hard for us to do any analysis. So we need to restructure them into a kind of structured process data set. You can see this lowercase here. So we have the student ID, an event ID, an item, and also event name, and what kind of actions he already used, and what's the timing over there. So our research draws on process data recorded in log files in the computer-based large-scale programs to address how sequences of actions recorded in problem-solving tasks can be related to the task of performance. Okay, why we want to do this kind of things and what kind of things we can learn from that. This is our motivations. So the first thing we think we can obtain insights. So how these sequence actions are associated with different ways of cognitive processing and to identify key actions that leads to success or failure. And our second motivation is we can use this kind of process data and to ongoing improve our test. The results can be useful for our test developers, psychometricians, and instructors to help them better understand what distinguishes successful from unsuccessful test takers, and may eventually contribute to improve our task and assessment design. And also the teachers can follow these kind of actions to help the students to get understand, okay, what's happened to the students, how they solve these kind of items. If we go inside to see the PS-TRE items, we can see there are some direct assessment, the main elements of the PIAAC. We have direct assessment like numeracy, literacy, reading components, and PS-TRE. I think the first three parts we have already learned quite a lot during the conference. There are very good articles here. And for the module on skills use, we focus on the cognitive skills, interaction and social skills, physical skills, and also learning skills. And the final dimension is we have the background questionnaire. We include in demographic questionnaires, education and training, employment status and income, use of ICTs and literacy and numeracy practices. And finally, we have social and linguistic background. So what we are focusing on is for the PS-TRE items. So PS-TRE items actually is named problem solving in technology-rich environments. The PS-TRE items are used to assess the skills required to solve problems for personal, work, and civic purposes. And our test takers have to set up appropriate goals and plans and access and make use of information through computers and networks. There will be more interactions involved with this kind of items, and it's only available in computer-based paths. Just now, I think Dr. John Sabatini has already mentioned the design of the PIAAC because we have computer-based paths and also paper-based paths. But for problem-solving item, because it's really based on computer-based testing, so only computer-based paths is available there. That's also easier for us to collect the data. And let me show you some PS-TRE item sample. Probably you have already familiar with this kind of item, but I want to highlight the different category one way to see these kind of items. So generally, we can divide the PS-TRE items from two categories. The first one is the single one, the single environment. Look at this item because it's rather simple because we only have one screenshot for the test takers. So the test taker just go over the spreadsheet here and to find information is needed. And then finally, he put all his result into this small box. So that's all. This is a very simple structure. And also in the PIAAC, PS-TRE items, we also have a little bit complicated ones. So this is complex with multiple environments. So you can see actually test takers need to go into the first screen and to find the correct website he need to click in. And after he click inside, and it will show like this way, and the test taker need to fill in more information. So that means they involve multiple environments inside. And our research objectives, we have two specific purposes for this specific project. So the first one is we want to extract and detect robust sequential action patterns that are associated with success or failure on one PS-TRE item. Because we have almost 10 items in the PS-TRE environment, but only one we focus on because each one will be very special. And we focus on one PS-TRE item just to illustrate how we can figure out the process data and do the action sequences analysis. And the second one is our purpose is we want to compare the extracted sequence patterns among the selected countries. That purpose leads to two specific research questions here. The first one is how sequences of actions recorded in problem-solving tasks are related to task performance. And the second one is our research question divided into two. And the second one is can the key actions and action patterns that lead to success or failure can be identified. And this is our sample. So we focus on 3 countries here. We focus on the United States, Netherlands, and Japan. Why we choose these 3 countries? The first thing is because there are more population involved in these 3 countries that can use computer-based paths. Because otherwise, for example, if we choose some countries that have a lower population that can use the computer-based paths, so it will influence our results. So we can have more population over there. And the second one is we want to compare, because United States, unfortunately, is a little bit lower. I mean, it is among the lowest performance in the PS-TRE items. And the Netherlands and Japan, actually, they rank very high. So we want to see the differences between these kind of countries. So altogether, we have almost 4,000 sample in our study. You can see this particular item is not that a difficult one. I mean, it's an easy one because we have more than 70% of a correct and almost 30% as incorrect. And we also check for their background data as demographic variables. We have gender, age, and educational level. I want to highlight here because so far we based on computer-based testing. So you can see here actually the population has a little bit higher educational level. Only except the Netherlands, because Netherlands seems to quite balanced in the less than high school and above high school. But for the United States and Japan, there's a more obvious to see the sample actually has a higher educational level because they can follow the computer base. And what kind of people can go to computer-based paths? Actually, it depends on 2 things. The first thing is they have the experience using computer before. And the second thing is they are willing to go into the computer base. They can choose if they think, okay, I'm not ready to go to computer base, so they can go to paper based. So that means when people go to the computer based path, so they're fully ready to do this kind of thing. And our instrument, because this PS-TRE item is not fully released by the OECD, so I cannot show you the screenshot for that, but I can explain a little bit. And the instrument actually we use a task is to identify the ID number of a specified club member. So we use a spreadsheet, so they can find the information from the spreadsheet and send his number to a correspondent by email. So that means it will involve 2 environments. The first environment is a spreadsheet environment that contains a database as a stimulus material that displays the information required to solve the task. And the second environment is an email environment. So in the email page, you need to provide the information you have already found from the spreadsheet. And the integrity score is evaluated based only on email responses. So that means if the test taker, he forget to type in, or he copied the wrong things, or he do something wrong, not on purpose, but he can still not get the correct score. Okay, so let me go into the methods part. Maybe it's a little bit technical thing, and if you think that is too complicated, so just forget it, and you can jump into the results. Because the methods part, I think that will be interesting to tell you, okay, how we do this kind of study and to validate our results there. Okay, the method is something like that. So we have all the students or all the test takers sequence like this kind of thing. So for example, the students just start, and then he click on the spreadsheet and do sorting and this kind of thing. And then based on these kind of sequences, and we find it has quite actually similar structure between the action sequences and the languages. Because when you speak one sentence or you write something, you cannot go back. It's just like the action sequence, you cannot go back because it just go in the direction and have this kind of sequence. So we find this quite a similar structure. That will be easier for us because we have quite a lot of model already facilitate into the natural language processing and the language analysis. So we can apply this kind of model into the action sequences. So we're motivated by the methodology of natural language processing and text mining. And we utilize the feature selection models in analyze the process data and a variety of aggregate levels. And finally, we will do some evaluate the different methodologies in terms to predict the power of the evidence extracted from process data. So I think N-grams model actually is the key point in our study. It's not that complicated. Let me illustrate a little bit to you. N-grams model actually is borrowed from natural language processing. It's just like one sentence I show you. For example, I am happy to give a talk today. So these kind of sentence can be disassembled into mini sequence, and we call them grams. For example, if I say, I am happy to give a talk today. So each word will be 1 gram, so we call them unigrams. And also we can have 2 words together, coexistent to each other, adjacent to each other. We combine them into 1 unit, so we call them as bigram. So you can see I'm happy to give, this kind of thing. And also we can have the trigrams here. Trigram just means I am happy to give a talk, like this way. So from this kind of way, we can disassemble this sentence into small pieces. Otherwise, it will be too long, that will be hard for us to do the analysis. And the same thing can be happening into our action sequences. So let me show you, this is actually one test taker sequence. It can be interpreted like this way. The student, he starts this item and he clicks on the spreadsheet. And in the spreadsheet, he chooses using the searching engine, and he types into his full name. And then he clicks on the email page. And email page, after he inputs his result, he clicks on sending. And then he clicks on next. So he's ready to go to next. And then he needs to double check. He needs to say, you are sure, you're confirmed to go continue on, or you want to cancel. So this student say, next, okay. And then he's adding this item. So you can see here, from this particular student action sequence, we can divide them into unigrams and bigrams and trigrams. And actually for the actions that always happening together, co-occurrence to each other, we can combine them into recoding things. For example, here, next, okay, and end, we can combine them into final ending, into 1 code. And we also need to give some term weights for each gram. So we call them inverse sequence frequency and damped term frequency. So it's like this kind of formula. It's a little bit complicated for the formula, but actually we divide them into 2 parts. And the first part, we call them inverse sequence frequency. This part actually tell you how often these actions can be occurred in the correct group and in incorrect group. For example, if all the students use the same actions, for example, all the students click on next, so this term will be very low. So that's mean because everybody uses one, it's not unique, so the term weight gives this kind of action will be quite low. On the contrary, if the students who have very unique sequence patterns, that weight will be higher. So it will be robust to help you to find them, to detect them out. And the second part actually is this part. We call them a stamped term frequency. The main idea behind this kind of term weight is like this. For example, if one student he click on next for 3 times, it should be different from 3 students, each one click on 1 time. So we want to distinguish this kind of weight. So we give this term over there. And then following, we give this kind of weight, so we can use our selection model. The selection model, actually, we use 2 of the selection model. We want to mutually validate our results. The first one, we call the chi-square selection model. So you can see this cube. Actually, A1 and B1 actually is the frequency of the actions occur in the correct group and occur in the incorrect group. And you can see this cube, actually, we can do 2 things. The first thing, we can aggregate them together. So you can see we just put all the correct things together. We aggregate them into a high level and incorrect group. And also we can do them by different countries. So for example, here we have the country level, the Japan, Netherlands, and United States. So each layer represents each country. So from this way, we can find which action actually is robust in correct or incorrect group. And if we change the cube a little bit to another angle, and you can find actually, we can find different features that are robust in each country. So for example, if we want to find the features that are robust in Japan group, so we can put all the Netherlands, United States, and all the other countries into another group. So if we do the binary classification, we can do like this. And following this formula as a chi-square binary classification, so we can do something like this. So we find the action with a high chi-square score. This is chi-square score. They are more informative in the classification. Therefore, we rank the chi-square score of each action in a descending order. And the actions ranked to the top were actually the robust classifiers. So this is the main idea behind the first classification model. We also use the second classification model. It's named the weighted log likelihood ratio. So the product of them, actually, you can find is also each sequence and logarithm of the ratio between conditional probability of the sequence in different performance groups. And also, the higher this score, WLR, the more likely the action belongs to class C. Conversely, the lower this score, the more likely the action belongs to the other class. So it's kind of a binary classification. Okay, let's come into the results. And I think the results is quite interesting based on these 2 classification models. So you can see first we do some results, features of actions by performance groups. The performance groups here, we have the correct and incorrect, and we just put them into the aggregate level. It's very interesting to find the robust classifier in the correct group. Actually, the correct group, they were using tools such as searching engine and sorting as a very clear sub-goal. That means in the correct group, you can find the test takers are more likely to have very clear sub-goals. They know what to do. So for example, here, they will click on the sorting, and then after they sorting the names in the spreadsheet, they can get the final answer. And then they click on the email page, and then they just sending in the results. And also you can find some people like this way. He make the typing. Typing just means he uses a searching engine to find the correct results. And also it's very interesting to find in the incorrect group. In the incorrect group, actually, the test takers show quite a lot of hesitative behaviors. So that means they use the cancel very a lot. You can see they have the next C. That means they click on next. So they want to go to next item. And when the screen shows whether you confirm you want to continue on, they will say, oh, cancel. Because they don't know whether he is pretty sure he wants to go continue to the next question. So you can see quite a lot of hesitant behavior over there. And also we find in the incorrect group, they're using help function quite a lot. And also they aimlessly save the result in the server. And the other interesting find is there is the response pattern over here is we find the start, next, final ending. So that means these kind of test takers, they do nothing. They didn't make any efforts to this item. Generally, it's a little bit hard for us to distinguish incorrect and missing data in the testing because we don't know what happened to them, whether they really don't understand this question or they make something wrong or they just skip this one. But actually from the sequence, you can understand, okay, this kind of test takers, he just skips this one. So if we find some test taker like this kind of pattern, it should be missing data, not really give them incorrect. And after we do this kind of performance groups, we also want to check whether each country can be comparable to our aggregate level and to see whether they have some different things or they just keep consistent. So you can see here, actually it's very consistent rate from the country level and aggregate level. So you can see from different countries, we have generally mean level of almost 80% of the agreement here. In the in-grade group, actually, we can find a little bit lower agreement. It's only 70%. So the implication here just means for the corrected group, actually, people do correct things almost similar. But when people do incorrect things, they have different variety way to do it wrong, right? So from the action sequence data, also you can find this kind of results here. Besides, we do the performance groups. Also, we want to see whether the country have their own unique features or robust features. So we do something like this. And for the US, Netherlands, and Japan, it's very interesting to find in the United States, actually, US people would like to double click on things. I don't know, it's a kind of a habit or something like that. But from the sequence data, we can clearly see that. So every time, so the test takers will double click on, for example, when they switch to the email page, they double click on that. So it's very interesting to find that. And in the Netherlands, actually, we can find the test takers more likely to use a searching engine instead of a sorting engine. And they will type in full name or the given names when doing the searching. And some result that's unexpected for us comes from a Japan group. Because in Japan groups, actually we find there are spelling mistake is the robust feature in this country. And we don't know why. So we go inside to see the Japanese version to see what's problem there. And we find it's very interesting to see they have a kind of optimal space between the first name and last name. So that means, for example, in English, definitely we have first name and last name, we separate them, and we have a space in between. But in Japanese or in Korea or in Chinese, we have the character-based things. Generally, we don't have this kind of space in between. But in Japanese, actually, it's optimal way. Sometimes you can find there's a space in between in some newspaper or something like that. But sometimes there's no space in between the first name and last name. But in the PIAAC, when we design the test, actually we say the space is compulsory. So you can find the test takers, they don't know there's a space, there's a must. So they just keep typing. You can see they're really persistent. And I remember one test taker, he typed in more than 30 times, and finally he changed his strategy to sorting. So you can see, yeah, really, you can see that, for example, you can see this one, the robust feature from the trigram, you can see this typing mistake, and typing mistake. But fortunately, we think the Japanese group, they are really good, persistent, and but this kind of, little bug actually do not influence their performance that much. Because the Japanese people, they are wise enough to change their strategy after they failed quite a lot of time of the spelling mistake. But you can see actually the process timing is quite long in this group because they persist on spelling mistake quite often. But finally they changed their strategy. I think that's good for them as well. Okay, and finally, we will also do some correlation between our two selection models to see whether they are quite consistent to each other. And we can find in the unigrams actually it's not that good, but the bigram, the trigram is perfect, agree to each other. So we find the chi-square and WR scores were moderately correlated in unigrams and highly correlated in the bigram and trigram in both the correct and incorrect groups. And it also proves that the mini sequences of bigram and trigrams are more informative in process data analysis compared with only single actions in unigrams, because actually when the student do something, actually it's a kind of sequence things, adjacent sequence. If you just put each actions by separately, so sometimes it cannot give you too much information. Okay, finally I will draw some conclusions and implications. So first thing, we find our process data play an increasingly important role in tracking test takers' thinking and action sequences, which is especially helpful in analyzing the problem-solving items, especially for this kind of scenario-based environment, and also in PISA, because PISA we have quite a lot of simulation-based things. And also the pilot study presented what we think now is a promising method to analyze process data and extract robust sequence features between different performance groups. And also this study also demonstrates our process data can be useful in detecting non-response due to low engagement of test takers and checking the item designs, especially in the field tests. For example, the space issue in Japanese version, if we can find them into the field test, that can be avoided from the main test. And finally, we think we explore this topic as part of ongoing improvement of the software platform used in PIAAC assessment for test delivery. And so we think the fruits of this kind of study will harvest later. And there are some future studies we are interested in. First one, we will keep ongoing use the data mining things and to develop a generalized toolkit for the sequence data analysis. And also we recommend including the background data and also the timing data in analysis of process data to further detect whether there are some interactions between them. And finally, we think exploration of how sequence data may inform adaptive testing appear to be a potential valuable research direction. Okay, finally, we want to thank all the support from our group, Center for Global Assessment and Data Analysis group in ETS, for their helpful information and data preparations. And there are two related publications to this project. If you are interested for that, you can send me email so I can share our publication to you. Okay, thank you very much.
So I think we should switch now to our discussant, and then we'll have some Q&A at the end. Dr. Rosen is a senior research scientist and a vice provost for advances in learning at Harvard. Prior to joining Harvard, he was a senior research scientist at Pearson, leading research and development of innovative learning and assessment technologies for higher order skills. Yigal was a member of OECD's Assessment Framework Expert Group. He obtained his PhD in education from University of Haifa and was a postdoctoral fellow at Harvard. Yigal is the leading editor for the recently published book, Handbook of Research on Technology Tools for Real-World Skill Development. Yigal?
Thank you. Thank you for inviting me to this session. So I'm really happy to be here, first of all, because of the great chapter that we have had in our handbook from the colleagues that have just presented here. And I think that it's really interesting, the kind of interplay of advancements in PIAAC and in PISA. So I will talk from the perspective of some of the work that I've done for PISA, especially the collaborative problem-solving domain. We're talking here about problem-solving, but actually collaborative problem-solving, this is the kind of extension of the problem-solving domain that was explored in PISA 2012 and also in PIAAC. So first of all, we'll start with the kind of a growing demand for performance assessments that report not only the outcomes, the results, end results of this user responses or test taker responses, but also on the processes that are involved. So we are really interested to see, what will be the implications, not just for this kind of summative large-scale assessments, but also for formative assessment or formative uses of this type of information that probably will be very, very valuable for feedback and also practice, teaching and learning processes. It's really important to see that in PIAAC and also in PISA, there is some, I think, new wave of constructs that are explored, right? So that will go beyond the math, or numeracy, literacy, science literacy. So in PIAAC, we can see the problem solving in technology-rich environments. In PISA, this is the collaborative problem solving, and recently in 2018, it will be a digital reading and also a global competency. So we go to more kind of high level of higher order thinking skills that are involved, that are not just focused on the conventional domains, but also on this what we call real world skills, real life skills. And one example was with this attempt to fix the problem with the PowerPoint here just a few minutes ago. When we see collaborative problem solving really in action, right? So a few comments or insights based on this interesting project was introduced here. So there is a two-step approach that was explored right now with one item in PIAAC assessment of problem-solving technology-rich environments. It suggests these two steps. So first, using the NLP representation model or N-gram model to explore relationship between sequences of actions to try to better understand what will be the optimal sequences of action that will lead the test takers, right, to the optimal solution. What are the challenges? What are the obstacles in these processes? So this type of work probably will inform some of the formative uses of this type of assessment, but also the implications for a better design of assessments, not just in PIAAC space or OECD PISA space, but more generally in especially in performance assessment space, where in many cases we can see new innovative items that involve more than just one possible way to solve the problem, right? They're open-ended, so there is a ability for the test taker to explore this space and take different paths to solve the problem, but also there is this growing demand to measure some of these skills like critical thinking or maybe creativity, collaboration, right? So in these cases, we really need some analytics tools that will provide us with the possibility to design these assessments, to kind of predict what will be this space of possible actions, possible sequences of actions that we will want to introduce to the test takers, and how these different sequences of actions are associated with the construct. Right, so it requires some discussion, for example, in terms of the definition of problem solving, or in PISA case, it will be collaborative problem solving, and how different solutions or different paths to solve the problem are associated with different proficiency levels of students. So I will give you an example from PISA collaborative problem solving. One of the major distinctions between the high proficiency in collaborative problem solving versus low-level type of performance is the ability to be proactive and try to work efficiently with partners. In problem solving, it will be, of course, the efficiency in taking the right decisions over this process of reviewing the spreadsheet and then going to the email phase. So there are different possibilities for the test takers, right, to solve this type of items, and we really would want to see, what will be the this space of possible solutions and how they are associated with different proficiency levels. So this point also relates to the implications for scoring. For the next phase of this type of assessment, would we want to have scoring systems that are associated not just with the outcome, but also with these processes. So Britt mentioned this possibility to work with the timestamp data, right? So some of this analysis will have to take into account the ability of the users, of the test takers, to take different paths to the solution, but also the efficiency of going through this process will be really important. So adding these aspects will be really interesting to see in the next phase. I think that this possibility to identify low engagement of test takers is really, really important. We know that in many assessments this is a major issue. So by using these techniques and some of the other techniques that are under development right now are really, really promising. I would suggest also to try to apply this approach to the other problem-solving item types in PIAAC, and of course trying to take this approach into the other assessments like PISA, maybe NAEP, and some of the other major large-scale assessments, and see how it works in different contexts, in different settings. It is possible that in problems where the difficulty level is much higher, or the open-endedness of these problems is involve much more kind of exploration from the test taker. This type of analysis will be really advanced through trying to better understand how it works in different environments, different test-taking environments. The implication for the formative assessment. So in this context of large-scale summative assessment, there is some opportunity, of course, to provide feedback to the test takers, but much more welcoming environment is really where we can share feedback with the test taker, and we can help them to improve their skills, right? So even if it's not real-time type of feedback, but if we can create some dashboards or some reports that will be provided to the test takers, but also maybe, for example, in K-12 space, to the teachers, to the schools, so we can improve some of these processes, some of these strategies that the students or the adult test takers will apply to this problem. So, for example, by showing different optimal ways to solve the problem, we can really increase the possibility for the learners to know, what is really expected. So it's not to say that we have to teach to this test. It's just to say that we can share this space of, what are these optimal ways to solve problems involved, and then, of course, different type of problems will be included in these assessments. But the idea of providing feedback, detailed feedback, and some practice in this type of assessment is really, really important here. Related to this scoring issue and reports, it will be really interesting to see this type of results, this type of analysis reported in the OECD publications beyond the outcomes. I know that there is some attempt to have this type of analysis included, and it will be really, really interesting to see how it will shape policy across different countries. And maybe just last comment, I wanted to leave enough time for the QA here in this forum. Part of my work right now in Harvard is really to try to bring these ideas from the assessment world, the formative assessment world, data analytics, into teaching and learning in HarvardX, for example, in this major initiatives to provide online courses to lifelong learners around the world. And I think that this type of analysis, of really trying to be focused on log files and try to identify different sequences of action that lead to better outcomes, not just in the assessment space, but also in the learning space, are very, very promising. So I think that some of this analysis will also apply to this learning environments, and not just into the assessment world. So thank you very much for really exciting paper.